Hi, welcome to Digital Electronics. In this particular topic, I will discuss in detail under Chapter 2, Octal Numbering System. So the outline of the chapter is 2.4, Octal Numbering System. In previous class, the hexa and hexa to decimal or binary has been discussed in subchapter 2.3. So we have covered the decimal, we have covered the binary, and also we have covered the hexadecimal, and also vice versa, which is going to decimal or going to binary. We have covered this. Now we are covering a new one, which is how to convert from octa to decimal, octa to binary, and lastly we're going to cover octa to hexa also. So in the previous class, I already discussed in detail how you understand your decimal number. This is base to 10. So it's always in a power of 10, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and so on. This is the decimal point. And for the fraction numbers, 10 to the power of -1, -2, -3, so on. So this is how 51.5 are being described at this particular situation. So it's done. So now we're going to focus on the octal section, which is the base to the 8. The symbols are involved from 0, 1, 2, 3, 4, 5, 6, and lastly is 7. So 7 will be the last symbol that can be fit into 1 bit, and the next level you need to a separate bit to process your data. So the octal number system in the representative, so you're going to have a normal decimal 0, which is also octa is 0, binary is 0 0 0. So you need 3 bits for this one. So 1 is 1, 4 is 4, and 7 over here your binary is 1 1 1 already, and the octa is 7. So this is the like earlier I mentioned, this is the final octa representative at this particular bit. So for the number decimal 8, which the binary is 1000, but in octa you cannot put 8, you need to put 10. So the 8 number is represented in octa as 10. Number 9 will be 1 1, number 10 will be 1 2, number 11 will be 1 3. So how a number 15 will be having 1 7. So there is a similar situation like this. So 7 will be the last representative for this bit, and when you have a 16 it will be 20. It's not 20, it's 20. So for the octal number system, it's always 8 to the power of 0, 8 power of 1, 2, 3, and so on. For a fraction is 8 to the power of -1, 8 to the power of -2, and 8 to the power of -3. So on. For example, if you have 47.23, okay, there is another point I need to remind. In octa, you shouldn't have any symbol of 8 or 9 because it is not available, because the number is only until 7. If you see over here, there is no 8. So if you have 8 or 9 over here, it will be considered as invalid. So please take note over here. Okay, 47.23. So you're going to have 4 and 7 over here. 7 times 8 to the power of 0. So you're going to use the first representative of 8, 10. And then the second one, 4 to the power of, 4 times 8 to the power of 1. So you're going to have another one, the next bit over here. So you're going to be 4 times 8, you're going to be 32. And for the 7 times 1, because 8 to the power of 0 is 1, and it becomes 7. 32 plus 7 is going to be 39. For this one, the fraction number 0.23. So for the 2, you're going to times with 8 to the power of -1, which is 0.125 times 2. You're going to have 0.25. For 3, you're going to times with 8 to the power of -2, which is 0.01562. This is the value, and when you total up both of these, you're going to have this. So 47.23 to the in octa is equivalent in decimal 39.29686 decimal. I hope this is understood to how to convert from octa to decimal. Next, we're going to decimal to octa. So you're going to have it's similar to previous section of hexa to decimal to hexa, but this one, because it's octa, you need to repeat by 8 method. So you need to divide by 8, keep the remainder, and repeat until you reach 0. So for example, you have a number 1193, you need to convert to octa. So 1193 divided by 8, which is this, the yellow part, which I put it as an imaginary. So 1193 divided by 8, you're going to have 149. So this 149, the actual number is 149.125. 149 put over here, and the balance 0.125 times 8, because you are dividing by 8. So you just time with 8, you're going to have 1 over here. So this one, the remainder, you just put over here as 1. So you follow the step. 149 divided by 8 is 18 point something. So then the remainder over here is you put the 18 over here and times with the point something times with 8, you're going to have 5. And then 18 divided by 8, you're going to have 2. And then so you put over 2 over here, and the point times with 8 will be 2. And last not but least, 2 divided by 8, you're going to have point 0 something, and that particular times with 8, you're going to have 2. So as usual, the MSB will be at the bottom and the LSB will be at the top. MSB is most significant bit, LSB is least significant bit. So you start from from bottom to top. So you just put 2251, 2251, and for the octa number. So 1193 decimal is equivalent to 2251 in octa. So you're going to see another self-check. So this is for you to understand. So you're going to have 1, 2, 3. Just convert this to octa number. So 1, 2, 3 divided by 8. So you can start to do this. So the solution is 123 divided by 8 is 123 divided by 8, 15. And at the point, you times with 8, you're going to have a 3. And 15 divided by 8, you're going to have 1 point something. The points, you time with 8, you're going to have 7. And 1 divided by 8, 0 point. Just put over 0 over here. The point times with 8, you're going to have 1. So MSB 1273. So you're going to have 173 as the answer. So to check this, you can always use your calculator. For example, if you have a Casio FX 570MS, so press your mode twice until you reach, you press number 3 to select the base, and then press octa and type 1, 2, 3, press equal button, and then press hex, press press decimal for the answer. Press octa for the answer. Number 2 is decimal, and this one is octa. Yeah, my mistake. I'm sorry. So quick check. We have covered the topic decimal to convert to octa. Decimal to octa is divide by 8, and octa to go to decimal, you need to times to the power of 8. So octa number system, how are you going to convert from binary to octa? So let's say this one, you have to do the grouping method. So how is similar to the hexa before, but in this case, you need to group everything into 3 bits per group before you convert it to individual or octa. Let's say you have a binary of this number. So just put everything, try to put from LSB to MSB, which is this side first. So the number 1 over here, put it over here. Number 0 is here, 1 is here, and then you're going to have 1001. So you're going to have 1001 and last 101 101. Since it is not enough for 3 bits per group, so you have an empty box over here. There is nothing over here, so you just put 0 as an extra header so that one group will have 3 bits. From here, you separate, you group up first 3 bits to this part, second 3 bits for this part, third 3 bits for this part, and last group to this part. After you form a group of 3 bits from LSB to MSB, make sure you start from LSB to MSB, and then just change the binary to your octa number. So 101, if you always refer back to your chart, 101 is 5. So you're going to have a 5 over here. So 4 plus 0 plus 1 is 5. So for this one, 0, 1, 1 is 1 over here. This is representative of 2. So you just put over 2 over here. 0 over here is 0. So 0 plus 2 plus 1 is 3, the blue color. So you're going to have 1, 1, 0. 0 over here is 0. 1 over here is 2. 1 over here is 4. 4 plus 2 is 6. And this one, 0, 1, 0. 0 over here is 0. 1 over here is 2. 0 always 0. And then 0 plus 2 plus 0 is 2. So for the binary 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, binary, when you change to octa, is going to have 2635 octa. Next, I'm covering up the converting from octa to binary. So let's say you have an example of 472 octa. You need to change to binary. How you're going to do this is using the expand method. So you need to expand your octa value into an individual of 3 bits per group. So first, you write 472 in your particular boxes. So you're going to have the first box of 2, second box of 7, and third box of 4. These 2, you need to expand it to your binaries. So 2 is 0, 1, 0. So you can always check your chart. Your octa is 2, so your binary is 0, 1, 0. You can use it over there. And then for 7 is 1, 1, 1, and 4 is 1, 0, 0. So for this particular, you just join it over here, 0, 1, 0. 1, 1, 1 will become over here, and 1, 0, 0 is over here. So you're going to have 0, 1, 0. So this is the first one, the first box. So the second box, 1, 1, 1. So you're going to have 1, 1, 1, and 0, 0, 1. So you're going to have 0, 0, 1. Okay, but in your writing, there is highly recommended to write every group as 4 bits. So in this case, you can write 0, 1, 0, 1. Here, 1, 1, 0, 0, or 1. Okay, for example, this singular bit over here, you can always imaginary add on another 0, 0, 0 so that it looks it can represent it in 12 bits. So for the quick check, so we have covered the decimal to octa before, and now we already covered octa to binary. So you want to change from your octa to binary. First, you need to expand into 3 bits per group, or from binary, you need to change to octa. So you can group it, the binary, into 3 bits per group from LSB to MSB. So you can get the answer. So this is a self-check for one. So kindly you can have a look how to do. Try to check on yourself. You can do octa to hexa, sorry, octa to decimal, decimal to octa. So there is 2 questions which a little bit challenging over here because it involves fraction and then going to have binary to octa and octa to binary. So you always can refer back to my notes earlier so that you can answer this one. So I also provide the answer over here, so you can always check your work. Next, I would like to go for the hexa. So we have covered the decimal to binary and hexa, and also we have covered the octa to decimal, octa to binary. But however, we not yet covered octa to hexa. So how are we going to do this? So for hexa to octa, there is no direct route. You need to either from hexa to binary, binary to octa, or hexa to decimal, decimal to octa. But for to ease of the situation, I always use hexa to binary, binary to octa. So it's much easier and more easy to represent. So for example, I have a question over here, example 5. FD8, you need to from hexa you need to change to octa. So first you write FD8 over here in the hexa number, and then expand each of the individual hexa to binary, which is hexa to binary. You can always offer refer to back my previous slides. So each of the bit in hexa is represented by 4 bits. So 8 is actually 1000. For D is 1101, and F is 1111. So you're going to have an expand structure like this. For the third one, just combine each of the group become one big binary numbers. So everything's going to be like this. So make sure on your right will be your LSB and the left side is your MSB. So it's same to your question. F is your MSB, 8 is your LSB. Then later you need to group or form one group of three consists of 3 bits because you want to change from binary to octa. So just form one group of 3, the first starting from LSB. So 000, this is one group, so you just form over here. 110, it will become another group over here. 111 will become another group over here, and 111 will become another group over here. So from these particular groups, you can change the data to octa numbers. 000 will become 0, 001 become 3, 111 become 7, and 111 again 7. So this particular representative is 7730, which is in octa numbers. And this is a representative of the answer. FD816 is equal to 7733 to the octa number. So we have done hexa to octa. Next, how are you going to convert from octa to hexa? So let's say you have an example 7421 in octa form. You need to convert to hexa. So first you write your octa number 7421. You're going to have these numbers over here. So each of the individual, because this is in octa, so don't forget octa is always 3 bits. Each of the box is represented by 3 bits in binary. 1 will become 001, 2 will become 010, 4 will become 100, and 7 become 111. So if you need chart, you can have a look on this one. So this will ease up your work, but you need to remind that such a chart will be always become handy to you. 001 then later on all the groups you need to recombine become one big binary numbers. So you're going to have group 1, group 2, group 3, and group 4 become one big binary numbers. So next, from the binary you need to change to hexa. So like earlier I mentioned, so one hexa individual is equal of 4 bits. So you start from 4 bits bit number 1, bit number 2, bit number 3, bit number 4. So this will become one group. 1000 become another group, and 1111 become another group. So from there, you need to convert to your hexa numbers. So 0001 become 1, 0001 become 1, and 1111 will become F. So on your right side is LSB, it started with LSB, and on your left side will be your MSB. So 7421 in octa is equal to F11 in hexa. So this is the self check for this task. So you might able to convert from your hexa to octa. So these are a few questions. So these two will be your challenging one, little challenging one, and from octa to hexa, this is one. So yeah. So this is the answer for both of the questions. You can always check with your answer with mine. And please continue to the document 2.5. We will talk about digital codes, BCD, gray code, and also ASCII. Thank you.